Yeah, all good. You can hear me well, no? Hearing no issue. So what are your names? Kaushik, Anirudh, Rohit, Princey. Princey, what's the surname? You're a Keralite. You're from Tamil Nadu only. Okay, okay. Princey is a very common name in my area where I'm from. I'm from Karnataka. I'm a visiting researcher here at IIT Madras. My laptop is acting funny. I wanted to show you a video, but my screen is playing games with me. Okay, finally it's here. Okay, so I am a visiting researcher at IIT Madras already. I told you this. We are going to study light reflection and refraction. I will handle physics for you all. I think this is your first physics class. Okay. So the area I work in, it's called high energy laser physics. We do not work with normal stuff. We use lasers for very high energy applications. Okay. And what I thought was, before we dive into this, I would just interact with you all since it's your first class. How many of you like science? Anybody like science? You can raise your hands. Okay. Anybody enjoys physics in particular? Hmm? Anybody here wants to become an engineer? And who wants? What do you guys want to become? What's your ambition? Nothing, not yet decided. But around what? Science, commerce? Any idea? No clue. What's your ambition? Graphic design. Wonderful. Hmm? Medicine field. Okay. Computer science. Okay. So the thing is, right now the world is like this, that not one field is separate from another. Everything is interrelated. I do a lot of coding work. Though I'm a scientist, my work involves a lot of coding. I do a lot of graphic designing work. In fact, there was something that I just designed for one particular experiment. This is a setup, laser setup. You know, the problem is the fan. No, it's my hair is all flying. Can I turn this off? Is that okay? Do you know where the switch is for this? There is. I'm not sure if that's for the fan. Okay, that one. Okay. This is fine, right? You're not feeling hot or anything, right? You can let me know if you want me to turn it on. Okay, so my job primarily here is to get you guys interested in physics, to show you what it is about. You don't have to take notes when I'm talking. Okay, that's absolutely fine. You guys follow the NCERT textbook, right? The same one, right? Everyone is following. So we'll be teaching from that. I'll be teaching you from this textbook. Anything and everything that you need will be in the textbook. Okay. So my main aim is, when I'm teaching you something, if you want some point you want to note down, you can note down. But you should listen with 100% focus. Because if you listen once, you will not forget it. You will not have to study again and again. Your job is done. Right? You're going to spend 1 hour here anyway. So do it very well. Correct? Okay? So I just thought I'll show you something because I wanted to get you interested in this field. Just wanted to show you what it is about. See, I don't know if you can see it. How do we do this? I'll bring it here and maybe you all can watch from here. Okay, can you see? So this is a video about the world's biggest laser facility in Romania. Okay. And it's very, very big. I'll just rush through, okay? See, these are lasers. This is light. Okay? And it's very powerful. It can cut through anything. With lasers, you can even find out the secrets of the universe. That's what they're trying to do right now. Okay? With light, we are trying to study the universe. We are trying to study space. Even black holes, you can study. Let's see. So, this, I just wanted to show you how the working of a few of these labs are. This is called ELI. It's one of the biggest laser facilities in the world. ELI stands for Extreme Light Infrastructure. Okay. Do you know what Einstein worked on? He worked on light. Okay. So many Nobel Prizes were given for discoveries on light. Can you see, man? You should tell me, okay, if you can't. Okay. I'll just rush through because I don't want to. See, they are using lasers to study nuclear physics. Okay. And this guy are here, his name is Dr. Ovidio. He's a very good friend of mine. Okay. Dark, have you heard of dark matter and things like that? Have you heard of dark matter? So using lasers, you can study things of that sort also. A lot of things can be done. But we don't know that because it's not very commonly, we don't hear about these things. Okay. So that is what the cutting edge research is right now. But we will study the very basic of light, the fundamental, the first step. Okay. And this will lead to your understanding of what is, it will, anything in the future, it will take you there. So, what is light? Anyone can answer, you can tell me anything. You can tell me a wrong answer. It's a form of energy. Very good answer. Power source. Interesting. Good. Anything. Source of energy. What do you think? See, he doesn't have an answer, and that's why he's right among all of you. Because even we don't know what is light. Okay? Yeah, what are you going to say? Very technical answer, very good. It's used to eliminate an object. Correct. All of your answers are correct. But the thing is, till date, we don't exactly understand what is light. If you take some light particle, is it a particle? Is it a wave? This question troubled scientists for so many years. Is it a particle? Is it a wave? Is light a particle? Can I have light particle? But that's the thing, light acts like particles. We actually work with light particles. They are called photons. I work with that. Sometimes light acts like a wave. So this property of light is called, you can just, I think in the introduction, the textbook talks about this a little bit. This property of light is called, or somewhere it just, talks about it. You don't have to write this down. Light, sorry. It's called wave particle duality. Okay. So this is just noted down as a note, but this is not the main thing of your studying or whatever of your subject. Now we will start now with the subject, and the subject is, the first thing we are going to deal with is we are going to look at the reflection of light. Okay. So what do you know what can you recall? I think you studied this, the laws of reflection. Correct. There's a second law. Correct. Okay. So the idea is very simple. When you take a look at very normal reflection, this is a surface. This is a normal. Normal is nothing but I'm drawing a perpendicular. It does not exist. I'm drawing it for my reference. You're understanding, no? Actually, I want to measure where light is falling on a, let's say here light is falling like this. With respect to what will I measure? So for the sake of measurement, to make things easier, I assume an imaginary line called the normal, which is perpendicular to the surface. It does not exist, but I am imagining it so that I can tell you what is the angle of incidence, what is the angle of reflection. Okay. So now the light will come out here. This is incident, and obviously it is a reflecting surface. So what will happen? It will reflect. So this is what I measure, this angle, and I call it the angle of incidence, because that is where the light is incident on the material. Now the laws of reflection, there are two laws which are very simple. The angle of incidence, this is your angle of incidence, will be equal to the angle of reflection, theta r, okay? I'm sorry if my handwriting is bad. If you want to make notes, you can make. If you don't want to, you just listen, okay? But one thing I want you to do, after going home, you go through the textbook, because everything that we are talking about, we are dealing with the text from the textbook. If you go through it once, you'll know everything. You may not even have to study things again. You just understand and remember, okay? So the number one rule is theta I is equal to theta r. Angle of incidence is equal to angle of reflection. Very simple. The number two rule is even simpler than this. The rule is that if a light falls are here and the normal is here, does that work? Light is falling here, okay? Normal is are here. Does that make sense? No. And the reflected ray is are here. Does that make sense? It doesn't make sense. So the rule is very simple. The incident ray, the normal at the point of incidence, and the reflected ray. Incident ray, the normal and the reflected ray are all in the same plane. They have to be together. They're considering it together. Simple? Okay? So what are the two laws of reflection? Anyone? See, we are not talking about the angle of incidence now, second law. Angle will be there. For angle to be there, what has to be there? Incident ray. So the incident ray, the normal and the reflected ray all have to lie on the same plane. It's called a plane. Okay? That's all. Fine? Now, there are a few properties that a mirror has for a normal reflection. We use it, you have a normal, see my reflection is here, your reflection is there. Now, what are the properties of this mirror? Can anyone tell me? What? Anything. You can tell me anything. There's no wrong answer. So, the first thing is, the first property is, see, you can tell me any answer, okay? You can even tell, sir, you are seeing yourself in the mirror. That is also correct answer. Okay. So the first thing is, when you look into your mirror, you see an image. Correct? That we know. So the first point is, this image that we see, it is erect and it is virtual. What is it? Erect and virtual. Erect we understand. If I am standing like this, the image will also stand like this. It is erect. It will not look at me like this. The image is erect. Virtual means the image is not real. We heard of virtual reality, VR. Does that mean, what does that mean? Virtual reality. It is not really there, but it is a type of reality which is virtual. It is an imagination, or it is something which is not real. Okay? So the image that we see on a mirror, can you touch that image? Can you shake hands with your image person? No. So is he real? No. He is virtual. He is in a virtual space. Everybody understood this point? Have you understood this point? Clear, no? So the first point is the image is erect and it is virtual. Okay? Now, the second point is that this is very simple. The size of the image is equal to the size of the object. When you look at your own reflection, is your reflection shorter than you on a plane mirror? Is it shorter than you? No. It's the same size as you. Okay. So, yeah. The size of image is equal to the size of object. Forgive my handwriting. And the third point is, any other points? Come on, you tell me. What do you think? Okay, first we said image is erect also, it is virtual also. Second, the size of the object is the size of the image. The distance. The distance between you and the mirror is the same as the distance between the mirror and the object. I mean the image. If you take one step in the front, the image will also take one step in the front. Correct? The distance is the same. Correct? So I think we can just say distance to from object is equal to distance to image. Okay. Now the third point. The fourth point is the image is laterally inverted. Laterally inverted means if you raise your right hand, your image will lift the left hand. Correct? If I raise my right hand, the image will lift its left hand, the other one. That's called lateral inversion. Okay? So what are these 4 points? You can just look at through and you can understand. The first point is erect and virtual. Second point? Third point? Fourth point? Laterally inverted. Clear? Okay. So now, but this is reflection of light. See, it's very late. We've already finished the reflection of light. Okay. So now the thing is, we are going to look into some special types of mirrors, some types of mirrors that even we use in the lab. So that's why I'm telling you, don't refer to these titles, okay? My content may not be related to that. Understanding, no? Because they are spaced here and there. Okay? Yeah. So now we are going to look into something called spherical mirrors. Spherical mirror is a very simple thing. If you take have you seen a curved mirror? A mirror is curved, that's all. That is called a spherical mirror. It's called spherical mirror. Why? Because they assume, now this is, let's say, your curved mirror. It is assumed that it is a part of a big sphere and small part you cut out. That is the thinking. So it is called spherical mirror. Understood? So using this kind of a thing, we define a few properties. Okay. Now if the mirror is bent inwards, this is called a concave mirror. Because why? Because the bend is inward, it looks like a cave. Concave. Okay, it's like a cave. You know, cave is bent like this. You can go inside it. Okay. Now, if the, sorry for this bad drawing, but this is the part of the mirror. Now, if it is bent outside, inside and outside, what I mean is, this part is reflecting, okay? Here, this part is reflecting. The bent part is not reflecting. Understood, no? Clear? So, this part is called a convex. Very easy to remember. The one which is bent side is reflecting, that is called a concave. It's like a cave, that's all. Okay. So now when we look at a spherical mirror and you look at the surface of the spherical mirror, not from the side, you look at, let's say, the surface of a spherical mirror. Now I take a mirror and when I look at it from the front, it is round. The center of this round surface I am going to call pole. What do we call it? The earth has what? A north pole and a south pole. Earth also has poles, magnets also have poles. This is simply called a pole. Okay? Fine. Now, the reflecting mirror, the reflecting part, it forms a part of a bigger sphere. We told that, right? Bigger sphere. So, the thing is, we call it, The bigger sphere, now if I take this mirror and it's a part of a bigger sphere, actually the bigger sphere is existing or not? It does not exist. See, don't get this confused. I'm taking a mirror, okay? A mirror is, or let's say this is the mirror. Sorry, I can't see. This is a small mirror. I can assume that it is a part of a circle, but the circle does not exist. I'm just making up these terms so that it is easier to do calculations. I'm not, that is the way it is done. Your textbook will also talk about this, okay? So actually the mirror will be what? It will be like a curve kind of a mirror, which is like this only. But it is not a circle. Circle will be what? It will be a ball. Have you seen what mirrors look like? Circular mirrors? You have seen them, right? They are not fully closed. They are only curved. Correct? So now it can be told that this mirror is a part of a big sphere. Understood? Any doubt? No? Clear? So now if this circle has a center, that center we call it C. This is the center of curvature. Okay? Alright? And this, actually what then they do is, okay, that's fine. And this part, now see, what is the pole and what is the difference between the center of curvature? Can anyone tell me? What? Can you tell me the difference between a pole and center of curvature? They are both looking very different. I mean, similar, right? Okay, you guys did not understand this. Give me a piece of paper. Any piece. This is very small. She's staring me. Okay. Okay. Fine. Let us assume that this thing here is a mirror which is bent. Okay? This is a mirror. I am assuming that because it is curved, I can say that it is a part of a bigger circle. The circle does not exist actually. But I am saying this. Why? Because it is easier for me to do measurement and calculation. How? If an object is placed, or if I keep this mirror here, okay, an object is placed here, I can do some measurements and I can relate it with the center of the sphere using geometry. Understood? Okay? So I am telling you simply, actually it is not there, that there is a sphere and the center of that sphere is called C, center of curvature. Because if there is some object here, I can tell you what is the distance between C and the object. Some relation I can do. Understood? But the length is only this much. Now, if I turn this is, now you understood? It will be like this. There will be a center. That is called center of curvature. Now, if I take the mirror and I flip it and I look at the face of the mirror, this will also have a center. This is called the pole. Two different things. Understood? 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 Clear? Perfect. Okay. So, this is called, I think I should, okay. So, this now I take, this is called this is a mirror, okay, a spherical mirror. The reason I am drawing these lines behind is, I am telling that this is a opaque surface. Okay, usually what we mean is, now a mirror will have one surface which is shiny another surface which is not shiny. So whenever I draw the line, I am telling this surface is not shiny, which means this side is the shiny side. Okay. So now what we do is we draw a line like this. Okay, we draw a line like this. This line is connecting. Previously, what we told there is a center of curvature. Okay, and it is connecting its pole. This line I am going to call principal axis. What am I calling it? Principal axis. Understood? It is connecting the center of curvature, it is connecting the pole, it is going through the center. Why I am assuming all this? For calculation purposes. We will do this soon, you will understand. It's very interesting. Okay. Now, there is also one more thing that we define, which is called a focus. Okay. The focus, okay, and the length from the pole to the focus is called focal length, small f. Understood? The length from the center of curvature to the pole, this one is called radius of curvature, r, because it forms the radius of circle, the sphere. Very clear? Understood this? So what are the different terms? Let's just go through this again, because if you understand this, your things are sorted. Center of this is called what? No. I took a mirror. I took its center. This is called what? Pole. The center of the surface. Okay? Is a pole. The center of Earth's surface, North Pole, South Pole, whatever. There is a pole. Okay? Center of the surface. Now I flip it. Okay? And I assume that there is a circle, but it's not there. And its center I have taken. So what am I going to call it? Center of curvature. Okay? Fine. And now I take the pole, I take the center of curvature. I am drawing a line through it. This is called the principal axis. Okay? Now, so the distance between the pole and the center of curvature, it forms the radius of the circle, right? Because center to this thing it will be radius. So that is called radius of curvature. Now there is another point which I am going to define. It is called the focus. Right? We have looked into that. The another point is focus. And the interesting thing is that the focus, twice the focus, we always reach the center of curvature. Okay? Understood? In one center radius of curvature, we get two focal lengths. Okay? The length from the pole to the focus is called the focal length. Clear? The length from the I'm muted. Press Ctrl Alt 8 or mute my microphone. I don't know how to do that. Okay, let's see. If something, I think they'll. I think it's fine. Okay. Yeah. Okay, from the pole to the center of curvature, what are we going to call it? Radius of curvature. All terms are clear. Surprisingly, the radius of curvature is 2 times the focal length. This is surprisingly. This is not, it is like what you know. Somebody took a light laser, okay. He took the mirror and he passed it parallel. And he found that all the parallel rays to the mirror, they are converging at a point. Okay, they are all meeting at a point. So if I take this one mirror, okay, and I take let's say some scientist is there. What's your name, man? Anirudh. Anirudh is a scientist. Anirudh takes a mirror and he shines light on it. Okay? Okay? And these rays are going parallel. Okay? Let's say 2 more. Okay? Anirudh does this experiment. He finds out surprisingly that this is the principal axis, okay, the line I've drawn in the middle, that all these rays are meeting at one point. Okay, this point is called, he calls the focus. Surprisingly, this focus happens to be half the distance from the radius of curvature. It is not calculated and it was not like he wanted it to be. This is the law of nature. It happens like that. Okay? Everybody clear on this? So what I want you to do is today when you guys go home, no, you guys go through the textbook and you will see everything that we have learned so far. Okay? And you will probably remember these things. Well, just before we leave the class, we will go through some things again. When you read once, you will understand everything and it will stick to your mind and your memory. You will not have to ever struggle for exams. You will not have to struggle for tests. This is a new, you should learn like this. This is how we do it. You have to understand what you're studying. Okay? Fine. So now maybe we will cover one more topic before we let you go. Okay? And for this maybe I want you guys to remember a few rules. Okay? Few rules. Okay? Everybody is ready now? We'll do it. Okay? So the rules are the laws of reflection. There are a few it's not the laws of reflection, but if we take a spherical mirror and we want to form an image, what are the rules that this image will follow? Okay? Now for example, there are a few rules and using these rules, we can construct any kind of an image. Now your cameras will do these kinds of things also, you know. I'll just show you these things and I'll even tell you how these things practically are. Okay? Now the interesting thing is this. I have already told you this. This is one lens. This is the center of curvature. The half of it is the focal length. It's the focus. Now, if a ray is parallel to the principal axis, where will it fall? I just told you, Anirudh was the scientist who did it. Where does it fall? It falls at the focus. So this one Anirudh discovered. Okay. Now, if the ray, similarly, if a ray is passing through the focus, the interesting thing is that it will then become parallel after reflection. Okay? Two rules clear? Parallel ray falls at focus, ray which is going through the focus will then become parallel. Very clear? Third rule is, the ray which is passing through the center of curvature, no, what do you think will happen? You are saying it will become parallel. I want you to imagine a sphere. Center of curvature is the center of the sphere. So if the ray will go center, where will it come after reflection? It will go up like this. It will go back where it came from. Understood? You have a circle. Ray came like this. It will go back where it came from because it's passing through the center. Correct? Any doubt about this, man? It is like going to diameter. You know, you have a circle. Ray is passing like this. It will go back and forth the same thing. See, this is my circle. Center of, look at the screen. Center of curvature. Light is coming like this. After this thing reflecting, where it will go back? It will go back the same route. Okay? Correct? Understood? Okay. If not understood, remember this. Regardless, you need to remember it. So the ray which goes through the center of curvature, it will reflect back the same route where it came from. If the ray is incident, if the rays, it says are here obliquely incident on the principal axis, which means if I have a ray and I make it incident on this pole region, no, it will exactly follow our law of reflection. The angle of incidence is equal to the angle of reflection. But actually the thing is that here then in the first three cases, is it not following the law of reflection? Is it? It will always follow that. So it's a law. Just that the normal are here, no, where will it be? Now for example, if this is the example, then the normal means what? It is perpendicular to the surface, so it will be like this will be a normal. So this will be angle of incidence, this will be our angle of reflection. It will always be followed. Understood? Okay. How many are clear with this? All are clear? Good. So can we look at the 4 rules again for image formation? When it is parallel to the principal axis, the ray will reflect and fall on the focus. Okay. When the ray is going through the focus, it has to pass through the focus. Okay, this drawing. Okay, after reflection, it will go parallel to the principal axis. If it is passing through the center, it will travel back through the same path. Okay, this is called the center of curvature. This distance is called the radius of curvature because it's half a circle. This distance is called focal length. This is called the focus. The center of the mirror is called the pole. The center of the surface of the mirror is called the pole. How many are clear with this? Raise your hands. Excellent, wonderful. Now using these rules, we are going to see how if I have an object, and I have this spherical mirror only, how will its image be formed? Okay, so for this, I want you to take your books maybe, okay, and I'm going to, you remember the 4 rules, right? Everybody remembers it? Good. So using these rules, we are going to see, no, not your textbook, close your textbooks, your notebook or anything, any book. I want you to draw and try this out. Okay? Any page, man, you don't have to. Okay? So you can draw this. This is your mirror. Okay? And this is your principal axis. Dotted means it is going very far, going to infinity. That is the only meaning. Okay, so have you guys drawn this? You can. Okay. So now I want you to, since you have drawn this, you can draw this focus, you can draw the center of curvature. So now what I want you to do is, I want you to tell me, let's say, everybody drawn this? Okay? Okay, so now look here. Let's say this is our object, okay, A and B. Okay, this A is not written properly. This part of the tab is not working, I think. Okay, AB. Okay, so now this is our object. Light is coming from infinity. This is at infinity. Okay, we are assuming that it is very, very far away. Light is coming from this object. I want you to continue this drawing for me after reflection, and I want you to tell me where the image will be formed based on the rules that we just learned. So every line, every ray which is parallel to the principal axis will fall on the, so continue the drawing. Relax, man, chill. It's all peace. So after reflection, where this line, it will go like this, it will go like that, it will go through this center of curvature, where it will go, that you have to draw. You just have to draw lines. That's your job. Just draw lines. Okay, can I take a look? Very nice. Yes, very nice. Very, very good. Yes, yes, that's the focus. It is all falling at the focus. Correct. Okay. So what I'm saying is, now this is the object. Okay, it's a very big object, A, B. Light is coming from this like this. It is coming in straight line. Okay. So after this reflection, no, it should fall at one point, no, all this light. So I'm asking, where will it reflect? So before this we discussed 4 rules, right? So parallel light, where it will go? It will go on the focus. So this will continue and it will all fall on the focus. Okay, that's all. Okay, so all these reflected light, it will form at the focus. Very good. So the thing is, the image which is formed now, will it be very big? It will be very small. It forms at one point. Okay, and this is exactly the kind of advantage. Where do you think there is an advantage to this? Object is at infinity. Object is very big object. Now if the size of my image was let's say there is Saturn, it is at infinity. You can consider it to be infinity. It's very far. Infinity means any far distance. Okay, that's at infinity. So now I want to take a picture of Saturn. If the image is as big as the object, the Earth will not be enough. Getting it? When you see the picture of Saturn, any planet, or you see the picture of the sun, the image is very small. Does the image of the sun, is it as big as the sun? No, because we cannot keep it on Earth. We will need a lot of this thing. So that's where we use something like this, which is very smart. Even your mobile phone does this. The object is really big. You take a picture of me, but the picture will be incredibly small. Okay? So this is the advantage. Did somebody learn something new today? Yeah, okay. Now we are looking into another thing, and this also you guys are going to draw for me using the rules before. Same type of a mirror we have. Okay, this is the focus. This is the center of curvature. Now the object is not at infinity. The object is, let's say, are here. It is closer than infinity. And now I'm going to draw 2 rays from this object. Okay, one ray goes like this, and another ray goes through the center. Where will these 2 rays meet? Remember the rules? Okay, what are the rules? The parallel ray will focus on the focus. The ray which is passing through the center will pass through the same thing. Okay, so draw the reflected rays. Are you getting something like this? Right? Are you guys getting something like this? So there is a point that you're seeing, no? Where these 2 rays are meeting. Correct? So this I can say, look here. This is where the image is being formed. Okay? So this is going to be our B dash, and we call this A dash. Okay? Sorry, I forgot what happened to this line. Just disappeared. Okay. Okay. So again, what we are seeing is that the image that we see here, it is smaller than the object. Correct? The size has become smaller. The image has become inverted. Matlab ulta hua hai. It has become ulta. If you stand in front of the mirror, your reflection will be upside down. Okay? So it has become ulta. And is it a real image or is it a virtual image? It's a It's called, now see, this is an important concept. There's something called a real image and a virtual image. Whenever the image is falling back into a real area, as in, now see, if our dear Anirudh, no, we have already taken his example. What's your name? Kaushik. Now, if Kaushik is standing here and the mirror is like this, the image is formed behind, that is called a virtual image. If it's formed behind, Kaushik cannot touch it, Kaushik cannot interact with it. Now, if the image is formed in the front, now this might be surprising to you. How can the image be formed in the front? It is possible. Okay, that is called a real image. If I take a mirror like this, I make Kaushik stand here. The light from Kaushik will go like this, and it will form at us. Let's say if I'm standing here, and that wall is the mirror, the light will come like this, and will form at a place called the focus. Okay, such that if I keep a paper here, I'll see mine or Kaushik's image on that paper. It will form out there. Okay, we can make a camera using this, a reflecting type camera. Okay, I can take a big mirror, some planet will be there. I'll put my paper or whatever thing are here, and on that the image will form. That's how pinhole cameras are made also. Okay, clear? Because light is being reflected, it will be like a tube light, bright thing. When you're passing light and you do some hand signal and all, and it will form like that kind of thing. Okay, are you clear about this? Now the rules about this, the reflection thing is that we can do many things. Now there is one more rule that we said, right? If the light is passing through the focus. So now I will do one more thing. I'll say from A, light is going to pass through focus. Sorry for my bad drawing. What is happening? Okay, light is passing through the focus. What will happen to this thing? It will become parallel. So this will become parallel. And where is it meeting? Same point. So you can use any rules you want on the object to find out where the image will be. You can use any kind of rule. Is that clear? Okay. Using this, we have a few more examples, and we have a few more examples, and unfortunately we'll just finish this, unfortunately we'll just finish this off before we leave for the day. Okay. So now the next thing is, again, draw this with me. There's a center of curvature, and there's an object. What's happening? There's an object, let's say AB, but where is the object now? It's on the center of curvature. So first example we took, it was at infinity. Second example we took, it was closer. It was not at infinity, but it was not at center of curvature. It was somewhere in between. So now the third example is, it is at center of curvature. So what we are trying to do is, we are keeping object at different points, and we are trying to see what the image will be like. Getting it? Okay. So now I want you to draw lines, whatever type of lines you want. You can follow whatever rules. Make sure that the lines you draw are from the top, from the tip B. Okay, it should always go from B, because you are trying to find the height, no? You can pass one. There are two things that are possible are here, two kinds of lines. Even if you are not sure, no, you try something, draw lines, no problem. There's no problem with being wrong. Okay, the problem is when you don't try. Okay, even if we try, we fail, that's okay, we are all learning. No problem, draw something, try it out. If you are not satisfied with your drawing, draw another one. Draw 2, 3 also, no problem. Okay, we are all figuring it out. I hope. Are you guys done? You can let me know if you're done, okay? If you need more time, you can draw things out. Okay? I'll draw it regardless now. and I want to, so first ray I will draw it parallel. The parallel ray will then pass through the focus. Okay, the second ray I'm going to pass through the focus, which will then become parallel. So the image that is actually formed, and now see that now this depends on your drawing skills. Okay, if you properly use scale pencil and all, the image will actually be formed are here. 1 minute. Did anybody get the image forming are here at the our center of curvature only? No, because our geometry is no, we are not using the correct this thing measurements. We are not exactly measuring it. Okay, and okay, but ideally the substance or the substance is that the idea is that if I, what is happening are here, eraser, let's see, very strange thing, I'll scrap this out. Okay, okay, this is my image. Ideally what should happen is after this, no, it should meet basically at a point something like this. It actually, if my measurements are correct, the image will form at the center of curvature only. Okay, we now, because we are not exactly measuring things, obviously in fact, you know what, I suspect that this is the exact center of curvature. Can anyone tell me why? Yeah. Okay. What is happening with this thing? I'm trying to erase it, is writing. When I'm trying to write, it is erasing. See, I erased the tip, the whole line disappeared. Okay. See, I'm trying to draw something, 2-3 lines are coming. I think I should erase this. Okay. Now, if you guys, anyway, what do I do? This, because I don't want to scribble something, because this is the PDF that you will get, no? They're going to give this to you, I think. 1 minute. Please forgive me. If you measure it correctly, and if we, maybe your teacher will make you draw with scale and pencil, okay? Finally. Okay? At the center of curvature, an object is there, the image will be formed on the center of curvature. Now, I want you to do this again quickly. Okay, we are going to, let's finish this off. Center of curvature, draw, if you can, try to measure it, center, the focus and the center of curvature, make it twice the length and all of that. Okay, that's when things will be very exact. So draw this again, and now we are going to keep the object a little more closer. So now I'll keep it between the center of curvature and I'll keep it between the focus. Now draw the rays and tell me what it will be like. Okay, maybe what we can do is do one thing, the height of the object, no, make it small, make it only this much, so that the lines are more exaggerated and you can see what is going on. Okay, always remember the ray will first go through the okay. Where is it falling? Behind the center of curvature. It's going far away, correct? I can draw two lines here. See, this is the way your textbook has done it. You could do it in a different way. They have just assumed that a ray comes like this. The ray, it is still passing through the center of curvature kind of thing, right? And if it reflects, it will go by through the center of curvature. Another ray, I take it parallel. Just should pass through the focus, and the idea is somewhere behind these two lines are meeting, right? Okay, but I can do the same thing that you have done. You have probably taken the second line through the focus, and somewhere it comes, and again it will meet around the same point. So the object is now the image is coming closer, the object is going further away, and the image is becoming, what is the size of the image? It is becoming bigger. The image is becoming bigger. Okay, so now we are going to do one final exercise, not final, okay, last but final exercise again. And now what? Okay, what happened? I'm not very sure. How do I go back? Okay. So now where will be the object now? Yes, very good. Draw your same two lines. You can draw three lines. You can try this one also. See, this line, dotted line, passes through the center, which means that there is a ray. It is actually following the same path, no? So it will follow the same rules. Okay, you can draw that also. Can we do it quickly? And I want you to remember, if you're confused, I want you to also remember, you can remember another rule that we discussed. At the pole, or light which is going to the pole will be, one is parallel, will be focused at the focus. A light passing through the focus will become parallel. Okay, then which was the other one? Center of curvature will go through the center of curvature. And the last one, light which is incident on the pole will follow the angle of incidence will be equal to the angle of reflection. You remember that one, right? Like this it will come, it will, okay. So you can even use that one here. Now your textbook will follow any two ray approach. It will show that only ray is following like this, right? Don't get confused. As long as you follow the rules, these four rules, any ray you draw, it will give you the correct answer. As long as your focal length is equal to, it should be half of the radius of curvature. That diagram you have to draw properly. So where is this image forming, man? More far. The image is never, you can say it is forming, but the thing is, the image forms, but the image forms at infinity. Okay, you want some? Yeah. It forms at infinity, correct? So now we are going to bring it closer. This is our last and final exercise. This is our focal length. This is our C, center of curvature. We bring the object even more closer. And how do we do this? I can follow the same rule. I can actually do this also, right? Or I can draw one more ray. Okay, or as soon as you draw, just look here. As soon as you're done, or I see, this is what most of you would have done. You can even draw. This will go where? Okay, this will reflect and it will go same path, no? So what you're seeing is, are the lines meeting anywhere? Draw three lines. Come on, you must have drawn two. Follow the, let's draw three and let's see. Are the lines meeting anywhere? Are they coming closer? They don't come closer. They go far and far away. They spread out. Yours is spreading out. Correct? That depends, man. We draw a little here, there, and all. That's okay. Okay, but okay. So the thing is, the image is never formed on this side because the rays spread out. But if we take these rays, no, that we drew, and if we extend it, right? They have done it like this. Okay. If I extend this, if I extend, and okay, this is the best because it follows the same path. It will form an object. It will form an image. Sorry. See, always the object I'm going to call it AB, right? And the image will be called A dash B dash. Huh? Yeah. Okay. So we see that the image is formed behind the mirror. The image is much bigger than the object. This image is called virtual. Okay, it's not on the real side, it's virtual. Okay. Now the advantage of this is, if I have some microorganism and I want to take an image of it, all I have to do is, now this is with the mirror, but I can do similar things with lenses as well. Okay, the rules are slightly different for the lens. We will look at it in the future. Okay, I can keep an object, let's say, okay, a mirror or something of this sort, or let's say I follow, yeah, I take a microorganism, I will keep it at the focus, or I will keep it at a place which is closer than the focus of the mirror, because I know what is the focus of the mirror, don't you? If you take a mirror, you will not know how to find out the focus. I can pass a light through it and I can measure where it is falling, right? Because a parallel light will always fall on the focus. Or I can just extend the circle and I can draw the circle, and if I take the center of the circle, I'll get the radius of curvature, center of curvature, and focus is half of that. So I can just do that. So I know the focus, and if we keep one microorganism, something very small is there, I'll keep it at the focus, there I'll keep it closer, and I'll pass light through it. The microorganism is very small, it is almost transparent, light will pass through it. An image is formed. The image that is formed is much bigger than the microorganism which I couldn't see. The image that will form will show me the entire structure of the microorganism because light can pass through it. Understood? Very clear? Correct? Okay. So with this, on this note, today, do you have any class after this? No. Okay. So on this note, we will wind up the class. So I want you to tell me if there's anything new that you learned today. Did you guys learn something new today? Was it interesting stuff? It was like, good stuff. So we will just recall, we'll go through, you can open your textbook for me if you have your textbooks with you. And go to page number, I think it is 160. You have your textbook, bro? No problem. You can just share with anyone next to you, okay? Okay. So, yeah. Let us go to page 161. What is the first thing we see? We see 2 points. What are they? They are the laws of reflection. I want everyone to look at me and tell me what the laws of reflection are. The angle of incidence is equal to the angle of reflection. Rule number 1. The reflected ray all lie on the same plane. Can we read these points from the textbook? The second point, what it says? The incident ray, the normal to the mirror at the point of incidence. So we have to be clear with our words now when we are writing in the exam. We say the incident ray, the normal to what? Kiska normal hai? Whose normal it is? Mirror. Normal to the mirror. Where? At the point of incidence. Simple? Okay. The reflected ray, the normal to the normal whose? mirrors, normal to the mirror. Where? At the point of incidence. And the reflected ray all lie on the same plane, because they cannot lie on different planes. It's common sense, right? Okay. And just if you go one or two lines, what do we see? It says, do you read that line? What are the properties of the image? These are the laws of reflection applicable to all types of reflecting surfaces. Correct? You see that line? And down if you go, we'll see that line, what are the properties of the image? Right? Do you see that question mark? Can you look at me and can you tell me what the properties of the image are? Don't look at the textbook. Come on, we'll try to remember. We discussed about this. The image will be virtual and it is erect. The size of the object is equal to the size of the image. The distance from the object to the mirror is equal to the distance from the mirror to the image. Image. No problem. And the last point is the image is laterally inverted. Okay? Good. So then if you go little more down, there is that activity 10.1, no? If you go under that box, don't look at that box. Same, page number 161 only. Page number 161. Do you see that line which says the reflecting surface of such a mirror can be considered to form a part of a sphere of a surface? Surface of a sphere. Correct? We talked about this. The mirror it's a part of a sphere. Okay? So such mirrors are called spherical mirrors. Then we looked into two types of mirrors. You are seeing the image of that. What are they called? Concave and convex. The one whose reflecting surface is going inside is called a concave, because it's like a cave. Okay? In a cave we go. In a concave light goes. That's all. Okay? So then if we go, and then we go to the last line on that page, page number 161. The last line, it says the center of the reflecting surface of the spherical mirror is a point called pole. Okay? And it is represented by the letter. So you all know this. Now next page, the first line, it says the reflecting surface. Okay. Can anyone read that first line?
The reflecting surface of a spherical mirror forms a part of a sphere.
Okay. This sphere has a center. The center of the sphere is called? This center is called center of curvature. And it is given by the letter C. Okay. Now if you go one or two lines ahead, you will see the word the radius of the sphere. Do you see that one or two lines ahead?
Yes.
So what does that line say? Can you read that for me? The radius of the sphere.
Which the reflecting surface of the spherical mirror forms a part is called the radius of curvature of the mirror.
So everybody understood this? The center is called center of curvature, but that length is there, no? That I'm going to call it radius, and it's called the radius of curvature. Okay, let us not look into these things more, because all then activities and all are there, but then on the next page you will see the relation which is written R is equal to 2 times F. You guys know this already. Okay, and then if you can you turn to page 164 with me. Okay, 164, the lower, now see there's a table over there, right? What does it say? The position of the object is at infinity, the position of the image is at, we drew this, correct? We understood these things. And what will happen to the size of the image? It will be very small, it will be real and inverted. Okay? If you beyond see all those things, you can go home and go through it again. The reason I'm taking you through the textbook is, you should be familiar with the textbook. Usually, whenever a person studies now, the first time they read it, no studying happens. You're only familiarizing yourself. It's usually the second or the third time that you're studying. I'm trying to do the familiarizing here only, so that you're already familiar with everything. And I want you to be confident. Whatever you're seeing or here, you already know it. after today's class. Is that correct? Yeah? Okay. So if you go to the, okay, now the table we know it, you can go through it. Okay. And if you go down, we see a point 1. What is that point 1? Can Mr. Rohit read the first point?
A ray parallel to the principal axis after reflection which pass through the principal focus in case of concave mirror or appear to diverge from the principal focus in case of convex mirror.
So the thing is, in order to not confuse you, I just took up the concave mirror. Okay. Now the similar thing can be done for convex mirror, and you can see it. What is happening? Instead of focusing, a concave mirror is a focusing mirror. Okay. It will take the light to the center as much as possible. The convex mirror is a defocusing mirror. So you're seeing that, right? The light which falls on this, now the focus is where? Are here. So it will, you draw dotted line that it is virtual. I think this is very easy to understand. It's just common sense, right? But the real ray is reflecting outside, but the focus of it is inside, right? Because the center where is the center of the sphere? It will be here. So it is the virtual image. That's why you're drawing dotted lines. In order to not confuse you, teach you both at the same time, I did this. If not, if you don't understand, go home and let me know. We can do this in the next class also. Okay. So the second rule, a ray passing through the principal focus. Okay, it is directed parallel. Okay, the same thing happens. Okay, the ray passing through the center of the curvature will just reflect and pass through the center of curvature. The last was the ray incident obliquely to the principal axis or towards the point P. It follows the law of reflection. And then the next page, 166, what you see is image formation. This also we have finished.